Good morning. Welcome to the Lionhearted Academy. My name is Richard Tai. This is our continuation in trigonometry lessons. Today is our lesson 21. We have talked about pretty much all the concepts that we need to cover. So today is a day that we'll cover some kind of problems and examples, and just let's go ahead and see what we can do with the concept we have learned. Okay. Alright, so one thing that we have learned so far is to be able to express the following as acute angle of theta. The acute angle of theta in first quadrant is always the most important angle that we will ever be using. We'll always be using. So whenever we have any kind of function, any kind of expressions in terms of theta, we want to express back in terms of theta. For example, we have talked about, like, for example, sine of 90 degrees plus theta. We can express this as cosine of 90 degrees, or excuse me, cosine of theta, right? Cosine of theta. And that's from what we have learned yesterday. Well, not yesterday, but the previous lesson, which I recorded yesterday, so to me it was yesterday. And sine 90 degrees theta is equal to cosine of theta. So this is a very important. There are other things like this that we can use. So for example, if I have, let's go ahead and try another example here from before. What about cosine? What about cosine 270 degrees plus theta? How would that be equal to? How would that relate to its original function of theta? Now, if you look at the notes from yesterday, if you look at the table from yesterday, you will see, oh, this is in the third quadrant, so it would be sine equal to sine theta, and so on and so forth. Okay, so we have those on table. And if you forgot those on table, you can go ahead and review that from the previous lesson. But let's go ahead and try something else. What about, let's try cotangent of theta minus 360 degrees. How do we express that in theta? Well, if you recognize that theta minus or plus 360 degrees is called the coterminal angles. Now, we covered coterminal angles in our previous lessons. That was a while ago. But coterminal angles is when you add or subtract 360. And anytime you add or subtract 360, you get back to its original equivalence angles. The coterminal angles are equivalent. And so that's why cotangent of theta minus 360 will be equal to cotangent of theta. Okay, let's try something else. What about sine 900 degrees minus theta? Okay, that was not part of our formulas from anything. But what we can do is we can find what is equivalent coterminal angle for 900. So what you do is you take 900, you subtract 360. So, okay, let me go ahead and put it here. So 900 minus 360, that would be finding one of the coterminal angles, 540. Now 540 is still kind of large, so let's go ahead and try to minus 360 again to see what is related to. So it's equal to 180 degrees. So now we say, oh, okay, so sine of 900 degree minus theta is equivalent to sine of 180 minus theta. And I think we have a formula for that, sine of 180 minus theta. We learned about that previously from the previous lessons. And this is allowing us, when you do 180 minus theta, that means we're in quadrant 2, because theta is we assume theta is starting with quadrant 1, so this will allow us to go in quadrant 2. And in quadrant 2, sine is positive, so it's equal to sine theta. So we can use several processes to simplify this process down to the simple process here. Okay, now let's try another one. What about tangent of 800 degrees plus theta? So let's see what we can do. So again, just like this previous example here, 800 degrees is a very large number, so let's bring it down to size. Let's bring it down to the familiar territory of between 0 and 360, and let's see what happens. So let's do 800 minus 360 is 440. So 440 is a coterminal angle. 440 is still too large, so let's minus 360 again. Okay, minus 360 again, so that will give me 80 degrees. So what this means, this is equal to tangent of 80 degrees plus theta. 80 degree plus theta. Okay, well, 80 degrees is not part. We don't have a formula for that per se, but how do we express this in using our theta only? Okay, now let's think about this. Okay, so tangent of 80 degree plus theta, I think that's the simplest we can do right now. Okay, have to go ahead and take a look at this again. Alright, so let's go ahead and try another one here. Let's try cosine of theta minus 90 degrees. Now we have not really done cosine of theta minus 90 degree, but if you visualize this in a diagram here, if you visualize what does it mean for cosine to be minus 90 degrees. If this is theta, if you minus 90 degrees, that means you're going to go right here. Okay, this will be theta minus 90 degrees, so subtract 90 degrees. And as you can see clearly, this will give us okay, the x value and the y value, they will switch again, so you will have to do with it's called function. So the original x becomes the negative y here, the original y becomes the positive x. So for cosine will be x over r, so this should be equal to sine theta. In fact, this should be equal to 270 plus 90 degrees. Okay, if you subtract 90, is the same equivalent of 270 plus theta. 270 plus theta. Alright, so let's move on to next set of problems, examples. Okay, so in this example, in this kind of problems, they will give us information. For example, they will tell us, let's say sine of angle A is 2/3. So they want us to find out the possible angles, sketch it, and then find the functions values of both of them. Okay, so sine of angle A is 2/3. That means angle A could be in two different quadrants. It can either be in quadrant 1 or it can be either in quadrant 2. So let's say if it's in quadrant 1, okay, if it's in quadrant 1, then it would probably look like this. Alright, and because sine is 2/3, right? That means, and you remember sine is what? Y over r. So that means the ratio for y is probably 2. The ratio for y to r is 2 to 3rd. Now their exact measurement we don't really know, but then we know their ratio will be simplified down to 2/3, because that's what this function is telling us. Sine A, angle A is right here. Sine of angle A is 2 over 3. Now this can happen in two different ways, because in quadrant 1 it happens like that. In quadrant 2 it also is a positive sine value, because in quadrant 2 the y value is also positive. So this is also positive 2 and 3. However, for let's call this A prime, okay, there'll probably be, yeah, this so let's call this A prime. So for A the y value and the r value are both positive. For A prime, y value and r value are also positive, but the difference will be their x values. Okay, the x values. So how do I solve for the x value here? Well, we can use Pythagorean theorem. Okay, so x squared plus y squared. Alright, let me go ahead and write it down here. So x squared plus y squared is equal to r squared. So we don't know what x is, but we know y is 2 and we know r is 3. Okay, so let's go ahead and work it out. So this is 4, this is 9, so x squared should be equal to 5, and then so x is square root of 5. So this guy will be positive square root of 5. However, x prime here on the left hand side will be negative square root of 5. Now why is that? Because x is in the second quadrant, is in the negative direction. It goes to the negative direction. Remember, this is the positive, this is the negative. So we have two angles. So therefore, we can go ahead and find out our function value now. So cosine A will be square root of 5 over 3. So x over r. Tangent of A will be 2 over square root 3. 2 over square root 5, or if I rationalize it, be 2 square root 5 over 5. Alright, and secant of A is 3 over square root of 5, or 3 square root 5 over 5. Cosecant of A will be equal to 3/2, 3 divided by 2, and cotangent of A will be equal to square root of 5 divided by 2. Okay. Now what about cosine of A prime? A prime is in second quadrant. Now, so in second quadrant it will be negative square root 5 over 3. And tangent A prime will be 2 divided by a negative square root 5. Okay? Negative square root 5. So that tells me the whole thing will be negative. Alright? secant A prime will also be negative. It will be 3 divided by negative square root of 5. So it's negative 3 square root of 5 over 5. Cosecant A prime will be equal to 3 halves, the same, because it doesn't involve the x coordinate. And cotangent A prime will be a negative square root of 5 divided by 2. Alright, so that's how we solve this kind of problem. Is when you given the information of a possible angle, given the information about the angle, we want to find the two possible angles. There are two of them, because there could be always two quadrants that satisfy this situation, and then we want to find their values. Alright, another type of problems that we will encounter is we want to express in positive acute angles. So for example, if we have sine of 155, we want to express this function using a sine of positive acute angles. Now we know this is equivalent to sine of 180 degrees minus 25 degrees. Okay, 25 degrees, and we can use sine of 180 minus that. So this will be equal to sine of 25 degrees, because there is second quadrant, it has the same I'm using the reference angle. The reference angle is 25, and so sine of 155 has the same sign as sine of 25. So what about cosine of 340 degrees? Oh, let's try something else. 232 degrees. Well, its reference angle is 232 degrees minus 180. Okay, well, it's actually not equal to that. Actually, I should say this is equal to cosine of 180 degrees plus 52 degrees. Okay, so the reference angle is 52, but because it's in third quadrant, so it's negative cosine of 52 degrees. Okay, it's negative cosine of 52 degrees. Alright, let's try another one. Let's try cotangent of negative 120 degrees. Okay, so cotangent of negative 120 degrees. Now, first of all, we don't want to write the negative cotangent, so we want to write it's actually equal to the opposite of a cotangent of 120 degrees, and we want to express this using an acute angle, right? So it's less than 90. Now 120 its reference angle is 60, and so it will be cotangent of 60 degrees. It will be equivalent to cotangent 60, because cotangent is negative in second quadrant, so it's negative times negative, so it will come out to be a positive cotangent of 60 degrees. Okay. Alright, let's try another type of problem. Now in this case, we want to go ahead and find all the function values of theta given the certain information. So let's say given tangent of theta is equal to 3 divided by 4, okay, and let's say secant of theta is less than 0. So first of all, we have two pieces of information, so that's two hints. And let's think about the first thing we want to do is determine the quadrant of angle theta, because that will help us determine everything, and we can make a sketch of it. So tangent is positive, but secant is negative. Now remember ASTC, the acronym, all students take calculus. Okay, so all student takes calculus, so ASTC. So tangent is positive in third quadrant and first quadrant, but secant is negative, so that means the only quadrant that's possible is in our third quadrant. So that means this angle is third quadrant. Now if this angle is third quadrant, what kind of triangle can we compose? Okay, what kind of triangle can we compose here? Well, tangent is opposite over adjacent, so the opposite value should be 3. Then the ratio of the opposite divided by adjacent should be 3 divided by 4. But because both of them are in quadrant 3, so both of them should be negative. So it should be a negative 3 divided by a negative 4. So the x coordinate will be negative 4, and the y coordinate will be negative 3. Now again, how do I know that? Because both of them are in quadrant quadrant 3, and quadrant 3, both x and y are negative. Okay, both x and y are negative. That's why we know they are negative. And then, as you can see, their ratio is positive, though. That's what it is telling us here. The ratio is positive, but each individual value is negative. So it's -3 and -4. So we don't know the r. We have to solve for the r by using Pythagorean theorem. So x squared plus y squared equal to r squared. Let's plug in. So it's -3 squared. Actually, it's -4 squared plus -3 squared equal to r squared. So 16 plus 9 equal to r squared. So r squared is 25. That means r is 5. And one note of caution here. R is always positive. R is kind of like the magnitude, kind of like the absolute value is always positive here. Alright, so we got everything we have. So now we can go ahead and figure out the measurement of the angles theta here. Not the measurement of theta, but the trig function values of theta. So sine of theta is equal to -3/5. Cosine of theta is equal to -4/5. Tangent theta we already know, so let's go ahead to secant theta. Secant theta is 5 divided by -4. And cosecant theta is 5 divided by -3. And cotangent theta, of course, is 4 divided by 3. It's positive because -4 divided by -3 is positive. Alright? Okay, so hopefully I have given you some different flavors of different problems that we can use our information to solve. And there are practice problems suggested from our text resources. Yeah, you may try to test yourself to see if you can do this on your own. If you have any other questions and comments, please leave it in the question and comment section. And then please also subscribe and share the video. And hopefully you will join us next week for the next lesson. We'll be moving on to talk about the graphs of trigonometry functions. So we're going to extend our unit circle concept to create the graphs of our unit circle function. Alright, thank you. We'll see you next time.